Dear colleagues, my name is Mykhailo Fryz, and I'd like to represent the results of our research titled as Electricity Consumption Simulation using Random Coefficient Periodic Autoregressive Model. The outline represents the logic of our computer simulation model justification. That is, we start from the continuous time linear and conditional linear random processes, which are representations of electricity loads. We consider the cyclostationarity property. Then we introduce the discrete time conditional linear random process, which is the mathematical model of electricity consumption. And finally, as the particular case, we talk about random coefficient periodic autoregressive model, which is the main building block for our electricity consumption simulation model. The modern problems and challenges in the energy sector require comprehensive scientific applied research in the domain of energy informatics, which combines computer science, control systems, and power engineering in a single methodology. The contributions of energy informatics depends on adequate modeling and computer simulation of energy-relevant devices, systems, and related processes. It helps to train and validate new approaches, avoiding collecting big data sets. Simulation of electricity consumption can be also element of modern digital energy ecosystem. A continuous time conditional linear random process is defined as the stochastic integral from the random kernel driven by the continuous process with independent increments, where the random functions phi and eta are stochastically independent. It can be easily seen that if the kernel is non-random function, then the resultant model is linear random process, which is a very important mathematical model of electricity loads. If the process with independent increments is the Poisson with corresponding jumps, then the physically reasonable model of electricity load is represented as the sum of large amount of random impulses occurring at Poisson times, and there are examples of such kind of impulses recorded from the household appliances. And if that impulses are considered as the independent, then the resultant model is linear random process. But there are a lot of reasons to consider that impulses as stochastically dependent and the corresponding model of electricity load as conditional linear random process. To take into account the cyclostationarity, we should consider the periodicity of corresponding probability characteristics of the investigated processes or signals, that is, the cumulative distribution function or characteristic functions are periodic with respect to their time arguments with the same period t. Also, there is another useful mathematical model which is a periodically correlated random process when we take into account the periodicity only the first and second moment functions of investigated signal. The discrete time conditional linear random process as the mathematical model of electricity consumption can be obtained from continuous time process by using the aggregation during the corresponding time interval, and the discrete time conditional linear random process then is represented in the following form as the corresponding stochastic sum, which is formed by the kernel, which is the random matrix in this situation, and generative white noise. The most important particular case of the above defined mathematical model is a random coefficient autoregressive model, which is represented in the following form, and it is formed by the white noise again, and there are the coefficients which are random in this situation. And there are the following characteristics of this model, which are the variance of the generating white noise, the non-random parts of coefficients, and the covariance matrices of the random parts of the autoregressive coefficients. And as we already said before, we going to take into account the cyclostationarity properties of investigated processes. That is why we need to apply so-called random coefficient periodic autoregressive model. This is the kind of the above defined model when the characteristics are periodic with the same argument. And the mathematical model has been used in the structure of electricity consumption simulation, which is represented on this slide. And according to the main building blocks of this simulation model, first of all, we need to specify the period of the simulation, the number of cycles we need to simulate, the order of model. After that, we need to specify the corresponding characteristics of random coefficient periodic autoregressive models. We should emphasize that characteristics have to be specified as periodic functions, and they can be obtained from the statistical analysis of electricity consumption data as the cyclostationary random sequence. Having that characteristic specified, we can then simulate the random part of coefficient, the cyclostationary white noise, then feed this white noise to the input of corresponding digital filter with random coefficients, and then adding the deterministic part, we obtain that our simulation of electricity consumption. The verification and validation stages cover checking the computer code for any programming errors, comparing simulated and real data visually, and using the statistical estimation and tests, etc. On this slide, we can see the example of simulation results. On the figure A, we can see the hourly electricity consumption of the enterprise belonging to the class of small and medium enterprise, and the figure B represents its computer simulation model. For the presented example, the mean absolute percentage error is equal to 15%. And if we talking about the further research intended to improve our simulation model, that we need to mention first of all the estimation and using the order of the model, using the non-normal distribution of generative white noise. We need to take into account the weakly cyclicity, and also we plan to utilize the higher order moments based or distribution based performance matrix for performance evaluation of our simulation model, and we plan to compare this model with our established simulation models. The conclusions are represented on this slide. Thank you for your attention.